use your textbook notes and calculator on these problems. You may not use any outside resources. Okay. So we can use the book.
Yes. All right. Let me get myself situated.
Book open. It's a lot of steps to get to this book.
Yeah, I need to pull mine up too. It really does take for so long. I don't know why. And mine takes forever to pull up every single time.
For the book? To load the book?
Yeah, every time I load the book, it takes forever.
When we first started, the book, every time it wanted me to download that Adobe thing. Every single time. And then I would have to just click on cancel, and then it would just read it.
Oh, really?
And after a while, it just like knew that I was gonna hit cancel or something. I don't know.
Okay, sorry, it's still pulling up. It doesn't make me do an Adobe thing. It just takes forever to like establish connection and do all that, you know?
Yeah. I don't know. It's weird.
Okay, so should we get started? I feel bad, but he hasn't said anything, so I don't know.
I don't know. I say let's start. And if he comes in later, we'll just kind of let him know what we've done.
Okay. So I'm just writing it down, I'm trying to be nice. I'll submit it today.
Okay.
You did it last time. Have you gotten your? I haven't gotten our feedback yet on that one.
I haven't even checked, honestly. I usually just leave it. I'm just like, we got what we got.
Mm-hmm.
Let me go see.
Sorry, I get really like anal when I have to turn it in, so I might be really slow. Sorry. When it's just me, my chicken scratch is just like all over the place, but because I can follow what I do, you know.
That's why last week it was so hard for me to keep up because you guys kept cutting out, and I was trying to kind of like write neatly, and then after a while, I just kind of had to give up.
Oh, sorry.
I just couldn't keep up with you guys.
You should have just said, "Hey, guys, slow down." Okay, so use is it Gaussian? Gaussian? I don't know how to say that word. Elimination to solve the systems of equation if possible. So this is the one where so it'd be 1, -3, and then -2 on the other side. And then 3, 1, -2, and 5. And then 2, 2, 1, and 4. Like that.
Yeah. Wait, hold on. Yes. Yeah, that's what I put. Apparently I lost my pencil.
Oh no.
There, I got another pencil. Huh.
Okay. And then And then we're just trying to solve it pretty much like the other ones, but just with the R, right?
Wait, what was that?
Is this where it's like, I forgot what it's, I'm trying to find it, where it's like you times it by the first row, and then the second row, and then the third row, like the order of operations or whatever.
Well, you want to get you want to, or at least for me, if you eliminate because right now the middle ones, you know where the ones are right here, kind of like going alongside the paper like this. Those ones we want to keep there as long as possible, but we have to turn everything else into 0. So I would start with the second row, and then go to the third, and just not change the first one until we get something close to changing that.
Okay.
Or actually, we could even do it now. Could we? I don't know.
No,
It's
all
up
the
to
homework
you.
ones had 2 equations. Right?
Huh?
I swear all the homework ones only had 2 equations.
Yeah, they did. That's why when I saw this 3 one, I was like, where do I start?
I wonder, since the first one, if we could eliminate the Z.
What do you mean?
Well, since it already has Y missing, could we eliminate either X or Z?
It has Y?
So there's no Y in the first equation?
Oh. Well, I don't know that. Um, yeah, I guess we could. The thing is that if we multiply, because the only one that we could change to get rid of the C on the top would be the third one, but we'd have to multiply all of that by 3, and then that first one will change to, it would change to a 7. So I don't know that that would be the best one to start with.
Okay.
I actually, huh?
I was just thinking, what if we did like to get rid of the 2, like times the third one by 2 on that one to get rid of the.
Wait, multiply the third one by 2?
Yeah, and then rid of the -2 at the top. That would be 0.
Yeah, we can do that.
But how do I know that that's what we're doing?
So the way we write it is just kind of like an arrow, just an arrow, and then you write out. So in this step, it would be 2 times, and I just use R for row because you're multiplying the whole row anyway. So I would write 2 R3 plus R2.
Okay. So then the first row stays the same because we're not doing anything with it.
Yeah, the first and third row stay the same.
And the second row is going to be 6. Oh crap.
4. Oh, wait a minute. Oh no, yeah, never mind. Yeah, so that would be 7 and 5. Oh, I don't know that we should do that.
You don't think that would work?
Well, I think we should start with changing the second one,
Okay.
because that one, we can get rid of that 3 by multiplying the first one by -3,
Okay.
and that way we don't get rid of those middle ones, or at least not yet.
So I'm going to rewrite this. So then now it's going to be -3 R1
Yeah.
plus R2.
Yeah.
So then -3, 0, and then 9 and 6.
Wait, what?
Don't you times it by -3 to that top row, so it's -3, 0, 9, and 6.
No, so you don't change the first row. The only row that gets changed is the second row.
So even though we are, you don't write it as changed.
We're just, so what we're doing is multiplying the top one, but we're just multiplying that and adding it to row 2 without actually changing row 1.
Okay, so then we have a whole new bracket with just those numbers without actually changing anything.
Well, yeah, like the first and third row will stay the same, and then the second row, that will be the first row times -3 just added onto it. So it would change it to let's see, it'd be 0 on the second row. It'd be 0. The 1 would stay the same, and then it's 9
7.
plus -7, and then 11. Oh wait,
Yeah, 11.
is it 11?
Yeah, because it would be
Negative,
6
yeah. Okay.
plus 5 is 2, 2, 1, 4. Okay. So I'm gonna clean it up, but this part right here is how we're doing it, right? So that's then it's -3 R1 plus R2, and then the new bracket down
Yes.
here. Sorry, I don't know what's wrong with my throat.
Oh, that's fine. You're fine. Now we should get rid of that third X on the third row.
Okay. So doing negative
now
to the top row.
Yeah, -2 to the first row.
So -2 R1 plus R3.
R3. You know what? Wait, what would that do? Yeah. Trying to figure out what it will do to it.
Let's try it.
So that would be,
the first row stays the same, second row stays the same, and then it would be 0, 2, -6 plus 1, -5, and 0. Oh, dang, I didn't do -2.
what? It was 0, 2, 6, 7,
and 8.
and 8. Oh wait, right? Yeah, and 8.
So I think we want to get rid of the what. So we're trying to get a 1 on X, 1 on Y, and then 1 on Z, right?
Yeah.
Okay. So -7
I think
to get rid of one of them.
I think if we did the second, if we multiplied the second row to get rid of that y on the third, we could then, after that, get rid of that 7 on the second one.
Okay, so -1 R2.
No, we want to get rid of the
I thought we wanted a 1 for each value. So we already have a 1 for y there. Oh, that would
yes.
make it 0 on that one, though.
No, we want that to be 0. We want the third y to be 0. So I think we should multiply it by -2, the row 2, or yeah, row 2 by -2, and then add it to row 3.
Okay.
And then let me see what it gets.
So 0, 1, 0, -3, -2.
-2 times 7 is -14. Plus 7, -7. Okay. Can I do that right?
I got 0. -2, -7, and -30.
Wait, you got a -2 on the bottom?
1 times -2 plus 2. Nope, 0. Sorry. So 0, 0, -7, and -30.
Wait. Did you add
Oh,
the
shoot.
8?
7 times -2 plus 8 is -14. Sorry.
Hey, that. Huh. And then we could just add row 3 to row 2 now. I think.
So R2 plus R3. Where do we put that
R3,
in the?
because that would make it as, oh no, we don't want to do that. No, we don't want to do that, because we want the 1 there.
Yeah.
Um, how do we do that? Oh wait, no. Yeah, if we add row 3, I was thinking it backwards. If we add row 3 to row 2, then it'll cancel the 7 on row 2. So it'll
Okay,
make that.
so row 3 plus row 2. So row 1 will stay the same. And then row 2 is now going to be 0, 1, 0, right?
Yeah, and then I don't know. So then it would be negative -14 plus 11. Maybe -3.
All right, so first row 1, 0, -3, -2, and then second row 0, 1, 0, -3, and then third row 0, 0, -7, -14.
I believe so. If we done all of our math right, that should be right.
Okay. Well, if we have the same answer, then hopefully that means we both right or both did it wrong. So now we somehow need to get rid of the -3 on the top one and the -7. We need to change that somehow to -1.
I think we should just multiply it. The third one. If we multiply it, but you would just divide it by, to make it 1, you would have to divide it by -7. But I don't know that they like that. So I would just multiply it by -1/7. Just the third row.
Okay, so
That would get us the 1.
-17 R3.
Yeah, -117 R3.
So then everything, so 1, 0, -3, -2, 0, 1, 0, -3, and then 0, 0, 1. Right?
Wait, what?
Yeah, -17 times
That's possible.
is 1, and then -14 times -1/7 is 2. So now we just have to get rid of that -3 on the top. So could we do 3 plus R1?
You said 3R3 plus R1?
3 R3 for row 3 plus R1.
Yeah. So
Because then we're changing row 1, but 0 plus 1 is 1. Same thing with the 0. And then that gets, oh, but that would change it to 0.
Wait.
Not, oh, we want it to be 0.
Yeah, we want that to be 0.
So if we times 3 times 1 minus 0, so 0. And then 2 times 3 is 6 plus -2, so it would be 4. So the new top row is 1, 0, 0, 4. Second row 0, 1, 0, -3, and then third row 0, 0, 1, 2.
Wait, 0, 0, 1, 2?
Yeah, 0, 0, 1, 2.
Yes. Yeah, that's what I got.
Okay.
So then we would just write that the x is 4, the y is -3, and the z is 2.
So x is 4, y is -3, and z is 2.
Yeah.
And then do we need to, oh, then we need to solve the equation. But that's easy because then we can just do 3 times 4 plus -3 minus 2 times 2 equals 5. So 12 minus 4 equals 5. Does that work? 5 equals 5. Yep. We did it. You did it. Look how awesome you were.
Oh. Yeah.
Do you mind if I hurry and just rewrite it while it's fresh in my mind?
Go ahead.
I'll be fast.
You're fine. This one I thought it was gonna be easy, but I'll wait till you I'll actually work it out right now, actually. A little bit.
Okay, Antonio, so this is what I did. Can you see it? I think we got everything.
Yeah, I'm just, yeah, it looks good.
Okay. And then, okay, so number 2. Two matrices that were the same size is called the matrix A and matrix B. A would K times A plus B equals KA plus KB for any constant K. Explain your answer using an example. All right. Write this down.
So I think I got this one.
Okay. Let me write this. Sorry.
Yeah. You tell me when you're ready.
Okay, I'm ready.
Okay, so how it says that we can make k equal any constant, I'm gonna use like the smallest, easiest things that we can do. And since it says the same size, I'm gonna use, a fun little size. So 2 by 2 is fine with me.
Okay.
So if we make k equal 2, and then if we make the matrix equal, the box, and then it's 1, 0, 0, 1.
Okay.
And then we make B 2, 0, 0, 2. Nice and simple.
So just to make sure I have this right, you said so k equals 2 and then A on and B 2, 0, 0, 2?
Yes. Yeah. And so then we would we would have to show the equivalent of k times the A plus B, so the first little part of that. So we would write it as 2, and then in parentheses both of A and B, both of those matrices.
Okay.
And
well,
then
could we add them first and then do?
That's what we're doing.
Okay.
So we're gonna, even though we're writing it, so we're doing the 2 outside of the parentheses, and then we're leaving both the matrices in the parentheses.
Okay.
So that then we would make that equal to the matrix. I don't know what to call it. The box.
Yeah.
3, 0, 0, 3, and then that's in a parentheses with 2 outside of it. And then that would be equal to 6, 0, 0, 6.
Okay, I guess what I'm confused about is okay. But where did the 3 come from?
Because you had 1 and 2. You had A and B.
Right, but k times A, wouldn't you do 2 times A first? Like, because it's saying it's equal to that. Does that make sense? So
Wait,
2
what?
times A, wouldn't you? And that would be itself. So you times it by 2, so it would be.
No.
That would make.
So I'm taking, so on the original equation where it says would k times A plus B in the parentheses.
Right. But I'm
That's
saying.
what I'm doing.
Okay, I thought you were doing the k times A because
No,
that's.
well, we can do that too first. I just, that's how I started. It was the first part.
That's cool. I'll start on the other side. So we have 2 and then a matrix that's 3, 0, 0, 3. Okay, I get it.
Wait, are you changing it then? Because if we change the matrix, we gotta just write down.
Well, that's A plus B, right? Is 3, 0, 0, 3.
Oh, you're still on the one that I was saying?
Okay, we need to start over again because I'm confused about where you're at.
No, where I was saying the 2 outside of the parentheses, you got that part?
Yeah, so okay, let's see. So 2 and then A plus B is 3, 0, 0, 3. Right?
Yeah, but you didn't so you didn't write the 2 and then have the A plus B inside of the parentheses?
So I did up
Oh,
here.
you did over there. Okay. Okay. And then yeah, and then you would
So
just
now can
multiply
we
that.
times that by 2 to get?
Yeah.
Okay. So it would be 6006, right?
Yeah.
Okay. And then we need to do the other side. So we need to. Okay, so that does. So 6006 equals 6006. Right?
Wait. How did you get that second one?
This one?
Yeah. So you did.
So 2
Oh, I
8
see.
is, so I just times, so up here I have written out 2 and then the matrix times 2 plus the matrix. And then this is timesing it by 2. So 2 0 and then 0 2, and then 2 times the b is 4004, and then I
Okay.
added those together and then got the 6006.
Okay. Yeah.
That makes
I
sense?
just didn't. Yeah. I just kind of. No, you did it a better way.
Well, not better, but it makes sense though, right?
Yeah. Yeah.
Okay.
Yeah. It makes sense.
Okay, so that's the using. So explain your answer using an example. Do we need to write words or can we just do it like that?
No, that was the example.
I know it says explain your answer using an example, so we don't need to write an example and then do the example, right? Like write M words like explain why. It just says to use an example, right?
Yeah. Yeah.
Okay.
Just that works.
We don't need to write a paragraph or anything. I guess.
No.
Okay.
If
So
we
then,
did, it would just be like, because of that, the beginning thing,
yeah.
k plus b equals, but they can see it with the work there.
Yeah. Okay. And then B, would you be able to multiply an M times N matrix with an N times P matrix? Size of the resultant matrix B. Okay. So I think I might need to go to the book for this one because.
So I remember, I don't know what page on the book, but I remember how, I can't, I got the notes from. Okay, yes. So I have the notes from the um, first meeting we had this week.
Uh-huh.
So I remember how one of them was not possible because the columns didn't match the rows on the other one.
Yeah.
So I think because on this one, they have the same number of columns on the first, the m times n, the n would be the columns, and then the
Okay.
second one is the n rows and p columns. So I think
So
it would.
M would be row, N would be column, and then
Yeah,
row, column. And
yeah.
because the column and the rows are the same.
Hmm. Then the resultant matrix would be m times p.
So I just wrote column and row are the same, so you can multiply together. Resultant matrix would be M times P.
Yeah, but I don't know. Do you want to write the first column or?
I kind of just did it like this, and I'll make it. I just put row, column, and then explain why, and then circle around.
Yeah, that works.
And it's just asking that and what the result is. So we're good on that one. Okay, and then 3, convert 0.181818 to a fraction by writing the repeating decimal as an infinite geometric series. Show all your work. Infinite geometric series. I'm going to look up my notes real fast. I don't remember doing one of these. Like, I just remember doing, like, where they give you multiple numbers, because then you find A and able to find the, like, the ratio and all that. So A plus AR plus AR squared is the affinity symbol with N equals 1 AR to the N to the minus 1. But you have to know the first one, right? I guess is that.
So I'm looking at the book on page 764.
764.
And they have a few examples. Yeah.
Okay.
I think 763, 764.
Okay.
Oh, I see how they did it. Oh, that.
Okay. 764. Okay, write the repeating decimal as an infinite geometric series. So we have to do 0.3, 0.3 times 10 to the negative 1. Okay. Okay. Let me go back to what our decimal is then. So then that equals 0.18. Should we do 18?
Yeah.
Plus 0.18 times 10 to the negative 1 plus 0.18 times 10 to the negative 2, and we'll do the 3 just like the example so we can.
I don't know that that's the same, because if you look at the B, if you look at example B, it's 1.2417, repeating 417. And if you look at what they did, they took the 1.2 out of it, and then they kept the 0.0417, and then they took the 417 and they used that as the base of what they would do the next one. And so that negative 4 that they have there, it's basically moving the decimal place over so that they would have the 417 as if it was just 417 in the front.
Okay.
I don't know if that makes sense, but because if you move it 4 places over, you have 417 And then in the next one where it says if you move it 7, so you would have another 417. And then 10, you would have it. So I think you move it every time that you get that amount, that first amount.
So you put a 0 where it is. So do we start with 0.1 or 0.8?
No, I would start at 0.18 and then add 0.18 times 10 to the negative 2, because in order to get 18, you'd have to move the decimal point twice to the right.
Okay, so first one is 0.18 plus 0.18 times 10 to the negative 2.
Well, first is the 0.18 and then plus the 0.18 times, I think they write it all out on yeah. I would just write it all out. Let me see. Negative 4 plus 1 times 10 negative 6. So I did so the regular 0.18, and then on the second one it would be to the negative 2. On the third one it'd be negative 4. On the fourth one it'd be negative 6. Then it basically just go up by 2.
Okay, so first one is 0.18 plus 0.18 times 10 to the negative 2 plus 0.18 times 10 to the negative 4 times or plus 0.18 times 10 to the negative 6.
Yeah.
Okay.
And then here, I don't know where to get that. I haven't gotten, this is the first time I look at this. I haven't gotten this far in the homework.
I don't remember doing any of these in the homework where they gave you a fraction. All of them started with a sequence already. You know what I mean? Like,
oh,
because lesson 4 is geometric. I did all the homework, geometric sequences and series. So it's a sequence in which there's a constant ratio between the consecutive terms. And then
why do they make that R? That doesn't make sense.
but all of these are like sequences. They're not given like a decimal and then you have to figure it out.
I don't understand why they make that R. This would be oh,
I think
negative 2. I think then it would be like 0.18 times 10 to the negative 2 over 1 minus 10 to the negative 2.
Sorry, say it again. I'll try in math. Let's see.
I think I'm not 100% sure. I'm just thinking that it would be 0.18 10 to the negative 2 power divided by 1 minus 10 to the negative 2 power.
1.18 times 10 to the negative 2? That whole
Yes.
thing?
Yeah, that very first one. But
that would give 9 over 4,991.
Maybe that's not right. Wait, 9 over what?
4,991. Okay, hold on. I think I'm going to try something real fast. So the common ratio, there's a formula. Oh, that's for the sum. We're not trying to find the sum. We're just trying to find, what are we trying to find? Convert to a fraction by writing the repeating decimal as an infinite geometric series.
What? What is that? Oh, that's right. Oh, that's so close.
I think it has to be 0.18 plus 18 times 10 to the negative 4 if I'm following the example on B.
Wait, 0.18 plus?
Yeah, 0.18 plus 18 times 10 to the negative 4. So what they did in example B is they put zeros in the placeholder. So we took 1/8 out, so it's going to be 0.001818 repeating.
Uh-huh.
Moved it over to 18 and then times 10 to the negative 4th. So what we're trying to do is we're trying to find the first one in this series. So we're going to convert, so 1.2 times 100. Okay, wait, I'm just looking at the. Okay. So what we're going to do is 0.18, we're going to times that by 100, and that's going to give us 18 over 100, just like an example, plus, so now we can find the ratio by doing 18 times 10 to the negative 4th divided by 18 over 100. So the golden ratio, so common ratio is going to be 18 times 10 to the negative 4 over 18 divided by 100 gives us 10 times 10 to the negative 6. And then we're going to plug that in. We're going to do 18 over 100 plus 18 times 10 to the negative 4th. 1 minus 10 to the negative 6. Is okay, so we're going to times this by 10,000 so that we get 18. And then it's going to be 10,000 minus 10. Okay. If we times the decimal by 100, we get 18.8. I'm just trying to think of what's easier, like to put it in. Okay. I'm going to set it up. So we're going to do times it. So I think 18 over 100 is correct. And then we're going to times that by 1 minus 1 over 100. And that gives us 18 over 100 times 1 over 99 over 100. So then if we do 18 over 100 times 100 over 99, those cancel out, and it's 18 over 99. Because, so A is going to be...
Oh my gosh, I just got it.
Did you get 18 over 99?
So, well, I don't know what it came up to. I kept using my calculator, but you helped me with when you said 18 over 100, because I kept doing the 0.18 over 10. But, and I don't even know why. If they should still be 100, but, so if you do 18 over 100, and then you add, it was 0.18 times 10 to the negative 2 power, that divided by 1 minus 1 minus 10 to the negative 2 power, that should equal, well, let me see. So let me do it again. So it's 18 divided by 100 plus, and then it was 0.18 times 10 to the negative 2 divided by 1 minus 1 minus 10 to the negative 2. Yep, and that would equal, well, we probably got to break it down, but it equals 0.1818181818. But we probably want the fraction. So 0.18 times 10 to the negative 2.
We're supposed to convert it to a fraction. So by doing that, though, it's just repeating back into the... It repeats back into the decimal that we were doing, right? So where you have to change it into a fraction.
Yeah, that I was just checking it. So if you do that, you just basically checking if you're on the right track.
Okay, okay, hold on just 1 second. I think I'm onto something, actually.
So if you take that down, you reduce that, it's 0.0018 over 0.99.
Okay, Antonio. So if you, okay, so I'm writing it out instead of the up to the negative 2 or whatever. I'm just doing it as decimal. So 0.18 plus 0.0018 plus 0. So I'm actually just going to do the first two, because if we know A, the first one is going to be 0.18. And then for the common ratio, if we do 0.0018 divided by 0.18, we get 0.01. And if we times that by 100, so that fraction 0.01 is 1 over 100. Are you following me so far?
Yeah.
Okay, and then if we do 18 over 100, and then we're going to times that by 1 over 1 minus 1 over 100 based on the formula that they give us. So that one, so that's 1 times 100 over 99, right? So then we have 18 times 100 times 100 over 99. The hundreds cancel out, and then we get 18 over 99. By 99 is 0.181818. Does that make sense? I have my work up here if you want to look.
Yeah. I'm just. Oh yeah. But we can reduce that though. That 18 over 99.
Can you?
Yeah. It'll reduce if you take it by 3. No.
Oh, no.
By
If we do
9.
by 9, it would be
Yeah.
2 over 11.
Yeah.
Okay.
But yeah,
So,
you're right.
but does that make sense?
Yeah.
I'm trying to do to the negative whatever, because that just confuses me.
Yeah.
Okay, I'm gonna write this out just while I have you here. So 3. All right, so we have 0.18 plus 0.0018 plus 0.000018. So 0.18 is the same as 18 over 100. Common ratio 0.0018 over 0.18. Okay. Okay. So if you'll look at that and see if you are okay with that for the work.
Yeah. Yeah. That's basically what the book.
You what?
Yeah. That's basically like the negative, rather than having the to the negative powers. So that works. Yeah.
Okay. Question number 2.
Wait, what?
I'm just going
I
to
thought that was.
rewrite question number 2.
Oh, you're rewriting?
Well, I didn't do it very nice, so.
Oh.
I'm a freak when it comes to this. Okay, but I don't have to do this while we're on the phone. Sorry.
No, you're fine.
But...
So do you want to do the what we've been doing, the just kind of going through the extension problems, and then if we need help, we'll just meet on Saturday?
I think that, yeah. I'm going out of town this weekend, so I don't know if I can meet, but I can definitely like get on chat or even.
That works. I'll just kind of say here on the chat that a certain time.
Okay. Okay. All right, I will turn in this and I will turn in our points for today as well. And
Okay.
then if we need help on the extension problems, we can reach out on Saturday. Does that work out?
Yeah.
Okay. Perfect. Okay, thanks for all your help.
Yeah. See
You're awesome.
later. Do we have a meeting? Do we have another thing next week?
No, but I think this is our last one.
Okay.
Because I think it's just the final next week.
Okay. I haven't even looked, so.
I think I don't know. I'll look again, but I'm pretty sure this is the last one.
Okay. Well,
Okay.
that's the case.
If you don't. Yeah.
Yeah.
It was a good 4 months with you. Good luck with your new baby and all that.
Thank you.
Exciting.
I gotta catch up on a lot of math homework and other class homework.
Yes. It's a busy time. Everything's due.
I'm just glad I'm. Are you taking like all year round classes?
Yeah. So this semester was heavy. I had like 17 credit hours, and then I have to take organic chemistry 2, the lab, and then calculus is all I'm taking next semester.
But when do you start your next semester?
In January.
Okay.
Yeah.
That,
Are you
that's
taking
what
classes?
I'm doing. Like, I started in. Well, when we started this semester, that was my first semester, and then I got one in January, and then one right after that one.
Oh
That'll
yeah.
be my
Yeah.
first year.
So. Exhausting after a while, but
Yeah. Well, this math did not make it easy. But
this is our hard class, like hard and really time intensive. Like,
yeah,
which I mean they about, but still kind of sucked. But
but
awesome.
We learned a lot, though.
Yes, that's true. I don't know if I remember it all for the final, but we did learn a lot.
I'm getting ready. I'm gonna go back and study a lot.
Yeah. Well, I'm kind of like math is something that if I don't use all the time, I forget how to do it. And so at the beginning of the semester, I'm like, no idea.
Yeah, and the good thing is that since are you taking it's calculus after this, right? Yeah, we're in pre-cal.
Yeah.
In calculus, we'll learn better things, and then as we go on, my wife revealed to me that we'll learn even easier ways, and basically the only thing she said that like the only thing that with my profession with studying to be an engineer, like out of this class the only thing that I'll actually use will be like the matrices.
Oh really?
So this part here.
Oh well, then you're going to handle on this.
Yeah. Yeah.
Well, why don't they just teach us the easy way at the beginning?
I wish. Yeah, I wish.
And then we'll be fine, right? And they can get another $100 out from us.
Yeah.
Anyway. Well, yeah, good luck with everything if this is the last time I talk to you.
You too.
Kind of weird.
You too. It's been fun.
Yeah. I'm glad we've been in a group. It kind of got whittled down there.
Yeah.
But you were open, so I really appreciate that.
Thank you. You have to put up with me.
No. It was awesome. Cool. All right. Well, if you like seriously though, if you need help or if I need help, we'll just chat on Saturday. Is that cool?
Yeah. Okay. Yeah. I'll make time.
Okay. Sounds good.
I got so much to do.
Yeah.
I'm so far behind on one class that I'm just like I don't know how I'm gonna get it done. I got a lot to do.
Oh,
me too. It's like an engineering class too, so I have to get it done.
Yeah. It's vital to your education.
That one is this.
All right. Well, cool. All right, I'll get this turned in. I'll just send it over tonight just so it's done, and then I'll just put in the chat box that I did it. Okay.
Okay. Thanks.
Okay. All right. We'll talk to you later.
Okay.
Bye.
Bye.
Bye.